Hello students, myself Amrita Dhar, Assistant Professor of Electrical Engineering Department of Greater Kolkata College of Engineering and Management, JIS Group.
In this video, I will discuss about polar curve. This topic is included in Module 2 of the subject utilization of electric power. Subject code is EE-702. Polar curve. Okay. Now, in order to determine illumination of a point according to formula E is equals to I by R square, it becomes essential to know the value of luminous intensity of the source of light in that direction. Now, due to various practical reasons, luminous intensity of various sources of light is not same in all directions. Distance of any point on the curve from origin gives to some scale the magnitude of luminous intensity in candela of source of light in that direction. If luminous intensity is measured in horizontal plane passing through the source of light and plotted for various angle, we get horizontal polar curve. Similarly, vertical polar graph gives the relationship of candle power in vertical plane and passing through the lamp at various angle. Now, typical polar curve of filament lamp are shown by this figure. Okay. This is vertical polar curve. Depression at 180 degree in vertical polar graph is due to the lamp holder and so depression at 180 degree in vertical polar curve is due to the lamp holder, and slight depression at 0 degree in the horizontal polar curve is because coiled coil filament occupies an arc which sustains an angle less than 360 degree. Next is mean horizontal candle power. Mean horizontal candle power. What is this? It is the mean of the candle power. Candle powers in all direction in horizontal plane passing through the source of light. Next is mean spherical candle power. Mean spherical candle power. Now it is the mean of candle power in all direction in all planes. It is the mean of candle power in all directions in all plane. Okay. Next is mean hemispherical candle power. Okay. It is the mean of candle powers below horizontal plane passing through the light source. It is mean of candle powers below horizontal plane passing through the light source. So this is MSCP, and this is MHSCP. Okay, now what is reduction ratio? What is reduction ratio? Reduction ratio of MSCP to MHSCP source of light is the ratio between MSCP and MHSCP is known as reduction ratio. This is known as reduction ratio. mean spherical candle power by means hemispherical candle power. Okay, this is the reduction ratio. Next is lamp efficiency. Next is lamp efficiency. Okay. Now it is the ratio of lumens emitted per 1 watt. It is the ratio of lumens emitted per 1 watt of electric power. Okay, so lamp efficiency is the ratio of lumens emitted per 1 watt of electric power. So sodium lamp produces 100 lumen per watt. Sodium lamp produces 100 lumen per watt. Mercury lamp produces 40 to 50 lumen per watt. Fluorescent lamp produces 75 lumen per watt, and incandescent lamp produces 12 to 20 lumen per watt. So these are the lamp efficiency. Next is specific consumption. Next is specific consumption. It is the ratio of power input to the source of light. Power input to the source of light to its luminous intensity. Specific consumption is the ratio of power input to the source of light to its luminous intensity. Its unit is watt per candela. This is the unit of specific consumption. Next is maintenance factor. Maintenance or depreciation factor. Maintenance or depreciation. Maintenance factor or depreciation factor. Now lumen output of all lamps decreases with uses. The condition in majority of industry are dusty. Unless there is a regular lamp and lamp fitting cleaning schedule, there is a bound to be depreciation in the light output due to deposition of the dust and soot as a dark film on the light source as source. Now deposition of dust and soot on the lamp is technically called as soiling of the lamp, and depreciation of light in addition to the soiling of lamp may be due to the soiling of lamp fittings and other reflecting surfaces such as ceiling fan and walls. Frequency of cleaning schedule much depends upon the condition prevalent in the particular industry. All the lamps and fittings are cleaned and at least once in a year. However, if work carried out in the premises gives rise to dust of fluff, and it may require cleaning of lamps more frequently. So we can say depreciation factor is equal to illumination under normal condition of old installation by illumination under ideal condition of new installation, and this varies from 0.8 for good atmospheric condition to 0.4 where atmospheric conditions are bad. Okay. Next is absorption factor. Absorption factor. Now, in case of foundries or places where atmosphere is full of smoke fumes and there is possibility of absorption of light energy. So, absorption factor is equals to net lumens available after absorption by total lumens emitted by source of light. Absorption factor varies from 1 for clean atmosphere to 0.5 for casting floors of steelworks and foundries. Next is reflection factor. So, all the light incident on a reflecting surface is not reflected. Some portion of the same is absorbed by the surface. So, reflection factor is the ratio between reflected light by incident light. Reflected light by incident light. Okay. Next is coefficient of utilization. Coefficient of utilization. Not all the light emitted by the lamp reaches the surface to be illuminated. Now, some portion of light falling within angle 1, I just draw the picture so you can understand it better. This is the working plane. Okay, working plane. One, two, two, three. Okay. Now, some portion of light falling within angle 1 will reach the working place directly. While other portion of the light will go to the walls falling within angle 2, and some of the light goes to the ceiling and falling within angle 3. Now, out of this portion of light, some will be reflected to the illuminated surface. So, coefficient of utilization is the ratio between lumens reaching the working plane by total lumens given out by lamp. So, coefficient of utilization is high for large rooms having light colored world and low for small rooms with dark colors. Now, next is the space height ratio. Now, in order to achieve even illumination and do away with dark areas, it is necessary that area illuminated by one lamp should overlap that illuminated by adjacent lamp. So, space height ratio is equal to space between lamps, space between a lamp by height of lamps above working plane. Okay, now space height ratio employed with dispersive type of reflectors, fluorescent lamps and other direct fitting is 1.5, and with concentrating reflectors it is 1. Next is the waste light factor. Next is the waste light factor. Now, in flood lighting scheme, a number of projectors lamp is employed so that light of each projector not only overlaps that of its adjacent projector, but at the edge of the area some light falls outside. In order therefore to compute total lumen required, theoretical lumen required are multiplied with waste light factor. So, value of this waste light factors is 1.2 for rectangular area, and 1.5 for irregular objects. 1.5 for irregular objects. Okay, value of this factor such as statues, monuments, etc. Beam factor. Next is the beam factor. Now this term is used in connection with projector lamp. It is the ratio of lumens in the beam of a projector. Lumens in the beam of a projector to lamp lumens. Now this factor takes into account the absorption of light by reflector and front glass of the projector lamp, and its value lies between 0.3 to 0.6. Next is a problem. Now if a lamp of 75 watt emitting 950 lumens is placed in a frosted globe of 30 cm diameter and gives uniform brightness of 250 milliamperes in all direction, calculate the CP, that is candle power of globe, and percentage light absorbed by the globe. So the solution is flux emitted by the globe, flux emitted by the globe is equals to 250 by 1000, 4 pi 30 square by 4, that is 706.5 lumen. Next is flux absorbed by the globe is 950 minus 706.5, that is 243.5 lumen. So percentage of light absorbed is equal to 243.5 by 950 into 100, that is 25.6%. Okay. Relationship between I, L and E. I is for luminous intensity, L is for brightness or luminance, and E is for illumination. Okay. Now consider a uniform diffuse spherical source with radius R meter and luminous intensity I candela. Then L, that is brightness or luminance, is equals to I by pi R square. Okay. Now E is equals to I by 4 pi R square into 4 pi, which is equals to I by R square. So illumination is equals to 3.14 into brightness L is equals to luminous intensity by pi r square, and E is equals to I by r square. So these are the relationship between I, L and E. Clear?
That's all from today's class. If you have any problem, please contact with me. My contact details is given on the first slide. Thank you.